Good morning. Today I am going to discuss one of the very simplest part of this activated complex theory, that is reaction between atoms. And you can call it, sometimes you can call it is an application of transition state theory, because I have already discussed theories of reaction rate, Arrhenius theory, collision theory and transition state theory. And I have also discussed the relationship between the collision theory and Arrhenius theory and activated complex theory. But today I will give emphasis on the reaction between atoms, and I can call it, actually in some books you will find it is an application of transition state theory. If I take two atoms A and B, or if I take one atom, another molecules, or I can take two molecules also, that is reaction between the molecules, but here I will concentrate only on the atoms. And second part, for the examination purpose, sometimes we can call it is a comparison of collision theory and activated complex theory. And as you know that today's derivation is based on the books Chemical Kinetics, K.J. Ledler, or you can refer other books like P.W. Atkins or Levine or Albert E. Daniels. So the objective is that how do you calculate the interaction between two atoms using the transition state theory and the collision theory. Now let me derive this thing. Now if I take actually reaction between two atoms, okay, so we all know that there is a collision, and then of course there is a formation of product, and that product part is regained that energy, and then as per the norms that when these two molecules collide, so there is no need of energy of activation. And if you know the collision theory for dissimilar molecules, so we have seen that this is equal to like that. Suppose collision diameter you all know, then 8 pi kBT reduced mass. This is the example of or final equation of the collision. So you all know all these things. And for the dissimilar molecules, or you know that it is reduced mass, so I can write like that. Suppose 1 upon Ma plus Mb small, you can write like that. So Ma Mb, Ma plus Mb. This is 1 upon mu. So if I have written here mu here, mu means Ma Mb and Ma plus Mb, because 1 upon mu is equal to this. If I write mu, so you can write in place of mu, we can write Ma Mb I just right here, you can write or this part. Or you can write like this. Only half E0 by RT. And in terms of molar concentration, so I can sometimes multiply it with the Avogadro number. In some books it is N or L. That is the normal thing. But now I have to calculate the same thing for activated complex theory. Now we know that there are three things: A, B, and transition state. So if we are talking about the transition state, you know that there are three types of vibration. I have already discussed these things. You know that for diatomic molecules, Cn minus 5 like that, degrees of freedom. And out of these three, some are translational motion, one is rotational motion, and remaining is, yes, you know this thing, vibrational motions. So a number of translational motion, this particular for different types of atoms. So there are three translational motions actually and two rotational motions. So remaining one is the vibrational motion. But here, while deriving this equation, we will not consider the vibrational motion or the vibrational partition function, because I have already discussed that when that reactant or these two atoms reach to that transition state, that molecule, that entity experiences loose vibration, acute vibration, and it decomposes. So we will not consider that vibrational partition function. So we will use only the translational partition function as well as the rotational partition function. So let me solve now all these things. One by one I will do. First I will do the transition state. Okay. So another, if I talk about the transition state, you can refer F, partition function F or Q, whatever it is. So here I am just using F of activated state, or whatever I am talking about, this AB stage. So we know, just before I discussed that I will consider the translational partition function first and then rotational partition function. So because it is in three directions, x, y and z, so I must write 2 pi. This is normal formula of the translational partition function. You know these things. MA, because it is reduced mass, plus MB by 2. KBT C by 2 HQ for 3 directions. Why I have written MA, MB? Because there are 2 reduced mass multiplied by rotational partition function 8 u square. I is moment of inertia, again KBT and H square. So this is partition function for the transition state. You all know that this moment of inertia is equal to always mr square. But here is m means reduced mass and r is your collision cross section, that is for A. And mu I have already told you, again we can write like that, 1 upon MA plus 1 upon MB. So MA MB, MA plus MB. So mu is equal to I should write in place of I MA MB MA plus MB, and it's quite big equation, otherwise, and derivation is very simple, only thing that you have to del square d I m r square. So now this complete equation you just see here, this is the for transition state, f this and this. Now I will write for A, because I am talking about the 2 atoms and 1 transition state. Now fortunately when this start, so only that translational partition function is responsible. So I can only write 2 pi m A, because this is for A. So KT, yes, C by H for A. For A. Similarly for B, 2 pi m B. Same thing. Just it is a sub. It is, you can write as just so now we have 3 values. Now we have 3 values. One is for A, 1 atom, another is for B, only difference is that reduced mass. And most important part, where we consider both translational partition function as well as the rotational partition function. Deliberately we are avoiding the vibrational partition function because it decomposes to the product. So now last stage is that we have to substitute all these in our main equation, that is the partition function equation. Okay, so let me just use the top part of this board. Just 1 minute. I should write first the formula of the collision theory, so that small one AB 8 pi kt ma plus mb because this is collision theory equation. Or under root you can write. Then exponential, same thing. E0. What is my objective? The relationship between the collision theory and transistor state. Let me check that formula of the collision theory so that there should not be any confusion. Otherwise, it is very difficult for me to explain the thing. So this is the final collision theory, absolutely no problem. In mole per, and if I multiply with that Avogadro number n or L, so it is the molar term. Now my last part, that means I have to substitute all those values in our partition function equation. That is the last part. Okay. Just see it very carefully so that there should be no confusion. So I can use the red color because there are similar equations. All equations are. So what is my final equation is that in terms of partition function, generally we write k, b, t or k, h, f. This is actually, you know, this is actually transition state theory, or k is replaced by delta g exponential delta g. This is the transition state form. And in terms of partition function, in place of k, I can write f a fb partition function. You know, you can write f, you can write theta, whatever you want, but this is partition function. Then I must write this f is partition function so that there will be no confusion. Partition function. Partition function. Okay. Now one by one I will substitute the things. So then again yellow color. This is the last stage, because you have to apply your common sense. So k is equal to kb t h. Okay. Now in place of f means the whole big equation, I will just write short 2 pi, because I have to write whole equation. So ma plus mb kbt 3 by 2 divided by h cube, no problem. Okay, then 8 pi square, then again kbt divided by h square, and ma mb ma plus mb d square a. Now I can rub this part. Okay, this part I can, otherwise it become clumsy. This part is over. Okay, now I have to substitute the a divided by, actually divided fa. So we need big board, right? So fa, if I write first fa, so HQ will be numerator side. So I can directly write, no problem. I must erase all these things so that so I can write first is that A. So H cube, okay, 2 pi m A kBt 3/2. For same thing for H cube B, 2 pi m B kBt 3/2. So first this H cube H cube H cube. So this you should this kb 3/2. Here is also kb 3. So this kb and kb square, or you can under root of kbt. So I can write k first the odd man. This is the odd man. So I can write a. Then under root of kbt like that. Okay. Now first let me solve it. Now here you can say it is actually MA MB. MA MB 3/2. Here is MA MB 1. So 1 might, if I write there, so minus half. So again, we just, so MA MB is already there. Now here actually MA MB 3/2. Okay, MA MB 3/2 power, and here is MA MB 1. So 3/2 minus 1. 3/2 minus 1. So that is half P. So plus MB. Okay. Now we need that, you see, if you see this pi cube actually, and here you see that pi 3/2 pi 3/2 I cube. So if you just solve it, I cube, and here is I cube 7/2, you just solve it, so half of pi. Now these 2 I can write like that, 8 I can write like that. 2, this 8 I can write like that. Mathematically, here is also 2 3/2, and in this side also 2 3/2, 2 3/2 plus plus. Now if I solve it, so I will get 2 3/2. So that is actually 2 cube means under root of 8, and that part is also there. E/RT the time is. So what I am getting? I am getting k is equal to, just you see this thing, del square. It is just a substitution. Automatically you will get it under root of 8 pi kBt MA MB divided by MA MB, or you can write simply mu and exponential E/RT. So is there any difference between the original derivation of collision theory and this theory? That means you can write, You can also write that 8 pi kBt divided by mu also, that is reduced mass. So what is the final conclusion? Final conclusion is that for reaction between two atoms, when we apply the activated complex theory using the partition function of transition state, partition function of atom 1, atom B, and substitute the value of partition function of the transition state. Only difference is that in transition state we consider translational and rotational partition function, and single atom we use simply the translational partition function for one atom, another atom. I have not no rocket science mathematics, it is just substitution, and just you solve it, so you will get the same equation we derived from the collision theory for dissimilar molecule. Molecule may be different. So that is the example of, you can call it either that the reaction between two atoms. Similarly, reaction between molecules is also there. Or how do you compare the collision theory or activated complex theory? So this is the simplest example of application of collision theory. Thank you very much.